Hello everyone, my name is Priyanka Parashar. I am a research scholar working in the area of building information modeling for safety. In today's class, I will be sharing some of my knowledge in this area. This class will focus on what is BIM and what are its application on construction safety. Let us start with what is building information modeling. It is commonly referred to as BIM. The first and important thing to understand is that BIM is not a software. Many people get confused and think that BIM is a software. There are numerous definitions available for BIM. The National BIM Standard defines it as a digital representation of a physical and functional characteristics of a facility as is shown in the picture. BIM is a shared knowledge resource for information about a facility which can be utilized for making decisions during the project life cycle, that is, from the conception of a project to its demolition. Now, let us try to break down the term and understand its meaning. BIM constitutes of three words: building, information, and modeling. The first word is building. It does not refer only to buildings, but all the sectors which are associated with construction. For example, roads, railways, bridges, tunnels, etc. It is a verb to the term build. The second word is information. We can say it is the heart of BIM, as the real value of BIM lies in information. It comprises information about the building, its components, properties such as function, shape, material, and processes for the building life cycle. The third word is modeling. It refers to as the geometry of the building. BIM uses various softwares for the modeling part, for example, Revit, ArchiCAD, SketchUp, Navisworks, Civil 3D, Tekla, and many more. In the construction industry, numerous problems and errors occur because there are certain flaws in the design phase. There are difficulties in communication of information and coordination among the participants of a project. We can say there is a separation in the design phase and the construction phase. Apart from these problems, there are several other problems that exist in the construction industry. A lot of such kind of problems can be solved if design information is communicated effectively. This is where BIM comes in. If we see in the current scenario, the architectural, engineering, and construction projects are becoming more and more complex because of the global trends and advancement in the technology. Since technology is also advancing, it is helping the industry professionals to work efficiently and effectively. Example of such advancing technology is BIM. It can play a vital role here. In the last slide, we discussed that the communication of information plays a very important role to overcome certain issues. In the left figure, we can see that it shows a traditional process of communication and information exchange among the stakeholders of a project. There are various stakeholders in a particular project, such as architect, structural engineer, MEP engineer, site manager, and many more other stakeholders. So it is easily understood by this picture that the information exchange is very confusing and chaotic. Whereas in the right hand side, the picture shows a communication with the help of BIM, and it looks quite easy to understand. In such case, BIM model serves as a database where information from all the stakeholders can be put in and can access the information provided by other stakeholders. So this is a good way to, or the effective way to communicate and exchange the information. If we talk about the design process, it has evolved with time. Initially, the design process was carried out by hand drafting. It was an extremely time consuming process. If changes were to be made in the drawings in any of the components, then it required a lot of rework to make the changes. It means that the chances for errors and omissions were pretty high. With the advent of CAD, a shift was made from hand drafting to CAD. With CAD, the industry professionals started drawing on computers and view their drawings on the monitors. Although CAD replaced the hand drafting, but it did not change the way in which information was displayed in a significant manner. Just like in case of hand drafting, there used to be numerous drawing documents for a single structure. For the CAD drawing also, the same situation was there. But CAD had an advantage over this, that it was less time consuming and also errors and omissions were lesser. Till this date, many professionals are still using CAD drawings. With the digital transformation, BIM has now come up in the industry, and owing to its numerous advantages, it is becoming the future of AEC industry. Unlike hand drafting and CAD drawing, there is a single model for a single structure, and all the related information is linked into a single model. In BIM, a model of a building is completely built in a virtual environment before the construction starts. This process is very much time saving and far less expensive to make changes prior than in the site during the construction. As BIM helps in cost saving, to quantify this, a researcher examined around 400 projects which were completed between the time duration of 2003 to 2009 with a project value of about $550 million, and he separated those projects into three categories, namely 2D projects where BIM was not used and the traditional 2D drawings were used. Second one was lonely projects where BIM was used but in a silo approach. Every stakeholder worked on their own using BIM. The third one was collaborative projects where BIM was used and it involved multiple parties or the stakeholders in collaboration with each other. He found that as the project teams collaborated, the cost saving became increasingly more significant as is shown in the picture. Hence, we can say that collaboration among the project participants play a vital role for using BIM. BIM is the process that connects and provides the AEC professionals with the information and tools to efficiently plan, design, build, and operate buildings. So we can say that BIM is more than just designing. It is not limited to just use in the design phase, but can be used in the entire life cycle of the project as shown in the figure. That is, we can use it in the planning phase, designing phase, building phase, operating phase, and even the this renovation and demolition phase. BIM can do the budget analysis, manage the material inventory, perform scheduling updates, clash detection, and much more. Till now, we have understood what is BIM, but there is a question why to use BIM? Construction professionals are using 2D drawings to deliver their projects and they are comfortable doing so. So, why to shift from 2D to 3D? Here in the slide, there are three pictures, out of which one shows a 2D drawing and other two shows 3D models. On visualizing all these pictures, we can see that the 3D model provides better, rather effective visualization of the final product before the construction has even started. In 2D drawings, there are different drawings for a single model. For example, architectural drawing is in a different document. Similarly, the structural drawings are different, MEP drawings are different, and etc. Whereas in case of BIM, within a single model, we can integrate all these aspects together in a single model. Other than this, we can integrate time, cost, we can do the energy analysis of the building and also do the safety management. There is a better communication among stakeholders in case of BIM. Everybody can see the model, the BIM model. So everybody knows what is happening in the project. Whereas in case of 2D drawings, everybody works on their own. So the communication is not that effective and the chances of rework are more than in the 3D model. Now comes the difference between the traditional versus the BIM safety management. As we have already studied in the previous lectures, that safety planning is an integral part of construction planning process. It involves the identification of all potential hazards and accordingly decide the safety measures. If safety planning is done effectively and efficiently, it leads to the prevention of accidents. Traditionally, safety planning is relying on manual observation and experience of the safety planner to detect the potential hazards. Such planning requires manual efforts, is time consuming, and also is considered error prone. Traditional safety planning is based on 2D drawings and schedules to understand the needs for safety equipment on a construction site. It is very difficult to identify potential hazards because 2D drawings are static. BIM, on the other side, helps the constructors to visualize site conditions, recognize hazards, and eliminate or reduce them before the construction starts. Now comes the BIM for safety. It is desirable to have a technology which may help in analyzing and communicating safety related issues. In the recent years, due to the growing application of BIM in construction industry, researchers as well as industry professionals have started using BIM to enhance construction safety. As BIM shows a visual representation of a facility, a BIM model allows the constructors to visually assess job site conditions and recognize hazards. This visual model allows the construction teams to assess site conditions and identify unsafe areas that might otherwise remain unnoticed until the construction team is on site. BIM can improve safety by identifying potential hazards in a virtual environment before the construction starts. It not only identifies the hazards but also helps to analyze why it happened. The potential hazards can be exposed floor penetrations, unprotected edges, exposure to equipment, etc. In this way, BIM connects the safety-related issues more closely to the construction planning process. BIM provides the methods to manage and visualize up-to-date plans and provide site information. BIM supports communication in various situations, such as informing site personnel to make arrangements in response to a particular risk or to provide warning against that risk. Despite all the technological advancements in construction, we cannot say that any digital tool can guarantee an accident-free workplace, and BIM is no exception to this. Nonetheless, it helps. According to a study, 37% of owners and contractors reported more than 5% decrease in reportable incidents due to BIM. With the help of BIM, as the rate of workplace fatalities are decreasing, BIM remains one of the most powerful tools to improve safety on construction sites. Here are few pictures to show how we can visualize the site conditions using BIM. The first picture shows the reinforcement fixing process. The other picture shows the movement of workers on site. The other one shows safety nets for concrete casting formwork, and the last picture shows a model which is presenting scaffolds on a building. Like this, we can create different scenarios and visualize them in a virtual environment and plan for safety accordingly. Now comes how can BIM improve safety in construction. For this, I have divided it into five categories, namely safety planning, safety training and education, prefabrication, design for safety, and automatic safety checking. In the further slides, we will be discussing them one by one. Now let us start with safety planning. How can BIM help in safety planning? So far, we have discussed that BIM-based safety planning is useful in identifying hazards and communicate the safety plans to workers. 3D BIM modeling helps in identifying and correcting errors that may lead to hazards earlier in the pre-construction phase. But the site conditions at the construction site keep on changing. Therefore, 3D modeling may not be that helpful. In such case, 4D BIM helps. 4D BIM means we integrate the schedule data into 3D model so that the safety is planned and monitored as the construction work progresses. 4D BIM is important for safety planning as it enables the visualization of safety arrangements at different times and provides more illustrative safety plans. 4D BIM model can be utilized in the design phase as well as the construction phase to detect workplace conflicts. 4D model is generated in the design phase and it can be used in safety planning for the site. A construction project has numerous tasks and each task has its own risks associated. BIM can focus on each individual task so that it becomes easier to identify the risks, arrange for safety measures, and complete the tasks efficiently and safely. During the construction stage, safety managers can access the BIM model and help in inspections and validate that safety provisions are being met or not. Here are the pictures to show the safety plans in a BIM model. The first picture shows the simulation of fire escape. These red markings shows the fire escape plan. The second picture shows a model of fall protection system. It shows the protection plan of edges and the floor penetration. Using 4D modeling, this fall protection can be installed whenever it is required and removed when they are not required. Such modeling can help in planning for safety prior to the construction. And similar to these scenarios, we can model for different scenarios to plan for safety. Now let us discuss how BIM can help in safety training and education. Any tool that supports safety training and education and reveals the unsafe conditions is of a great value to the construction team. BIM has shown its abilities to provide training for workers off-site by increasing their awareness about the hazards by visualization of various facilities such as scaffoldings, guardrails, etc. A person's ability to understand the abstract concept can be enhanced with the help of visualization. Visualization or the animation is an effective method for understanding the safety related issues. This is important especially for the new workers at site who are unaware of the site safety measures. With the help of BIM, such new workers can understand the construction processes in a better way. Another thing is the language barrier. At construction sites, there are many migrant workers present who come from different places with different languages. They may or may not understand the language of the place where they are working. In such case, providing safety training is difficult. But BIM helps in overcoming this language barrier as visualization can help them understand all the related issues and processes. Now let us discuss prefabrication. When we move our work to a warehouse environment, it greatly reduces the risks of hazards such as slips, trips, falls, and other injuries. BIM and prefabrication has led to many favorable scenarios that help in reducing the risk. BIM helps in automating the work on site, which leads to safer projects. We can simply say that reducing the amount of man hours on site reduces the chances of incidents happening on site. A construction company claims that BIM-enabled prefabrication has allowed them to eliminate thousands of trips climbing up the ladders and lifts and also to eliminate thousands of hours of hot work and general construction activities in various situations. While prefabrication seems a perfect solution, but it can cause more damage than good if not utilized in a correct manner. This is where BIM helps. BIM helps in designing the prefabricated material effectively. The problem of the risk that whether the parts of prefabricated material will fit together on site or not, this risk is resolved by BIM as the BIM model is highly detailed and consists of each and every bit of information. Next is design for safety or the prevention through design. You have already discussed about DFS earlier in the previous lectures. So we know by this time that design for safety is the process where engineers and architects consider safety during the design phase. The potential hazards and risks are designed out in the design phase itself. Researchers have established that there exists a relationship between design and accidents. Usually the accidents occur during the construction phase, and improper safety planning is the major contributing factor behind the occurrence of accidents. Many researchers have focused on design and planning stage of the project, which shows the efficacy of BIM in preventing the accidents through design. BIM helps in providing safety suggestions to the designers, engineers, and constructors. When the information is acquired earlier in the project lifecycle, it allows the teams to get aware about the issues and address them at earlier stages. As seen in the picture, safety suggestions are made available using BIM. So there is a staircase component which has been highlighted, and there is an issue regarding the flaw in the design which is made available, that there is no parapet in the staircase. Similarly, we can identify such issues as design flaws using the BIM modeling. Last but not the least is automatic safety checking. It is also referred to as automated rule-based checking or automated code compliance checking. As the term indicates, we can understand that it has something to do with rules or the codes. In simple terms, we can say that it is a process to automate and check against the set of rules. It is defined as a computational procedure for addressing the manual regulation verification problem in a finite number of computable steps. It means that the safety rules and regulations which we have in a human readable format, those are converted into a computer readable format. It is a piece of software which does not modify a building design, but it evaluates that building design whether it is following the set rules or not. It assists the user to define and apply rules into the model and get the reports in return. The results generated are in the form of pass if the rules are conformed to, fail, warning, or unknown if certain a set of constraints are missing. BIM allows an environment where these codes and regulations can be verified automatically through software application, which otherwise is done manually. There are four components of automatic safety checking. The first one is rule interpretation, which involves the translation of human readable set of safety regulations into the computer readable form. The second one is building model preparation, which involves building of a model wherein we have to execute the rules, the converted rules. The third one is rule execution, where we have to apply the translated rules into the building model. And the fourth one is rule checking reporting, where we get our reports or the results. And there are two forms in which we can get our results. One is the visual forms in the model itself, or in the based or the Excel based reports. That was all about how BIM helps to enhance safety in construction sites. Now let us move on to some examples. BIM has been used by different construction companies to enhance safety within their organization. Some of them are listed here. One organization used BIM as a tool for automated logistics and prevent safety incidents. They used 3D BIM modeling to run through all construction and installation details before the construction team go to the site. Another organization found BIM to be an effective way to eliminate risk to welders. They used BIM to detail concrete and steel so that they could cast embeds and attached beams 4 levels up in such a way that the workers need not go up an elevator shaft and weld it. The New York City Department of Building has started to use BIM processes and tools to validate construction site safety plans. The submission processes of the safety plans, emendation, and review is now fully digitalized and BIM based. Like this, there are several construction companies who have been using BIM to enhance safety. These are the references which I've used to prepare the content for this presentation. I've used few books, some research papers, and some internet resources. Thank you.